Hello everyone, Ankesh this side. Today's this session is about uh, connecting ESP32 using JTAG and flashing a bin file over the JTAG in the ESP32. Uh, JTAG is also one of the protocols which is actively used in the debug of microcontrollers as well as processors. JTAG stands for Joint Task Action Group, and it is little bit, I'll say, no, it is considerably more fast than serial wire debug SWD that we have done till now, and it also offers a host of other features over SWD. So in this session we are simply going to do a write of firmware in our ESP chip using the JTAG interface, while in subsequent sessions we'll dwell deep into it and we'll find out what else we can do using the JTAG connection. So let's move ahead. Okay, so first I have already prepared a chip that does not have anything flashed into it. It is practically empty. We'll first test it. I am going to connect it to the laptop, and first we will give it permission using the chmod, as we have already seen numerous times in the previous videos. So the permission is changed. Now the port is accessible to us. Let's run the monitor and find out if our program is there inside the chip or not. So as we can see, there is some noise in between. I think the cable is not connected properly. I'll run the monitor again. Yeah, now we can see that the processor is in reset state. There is nothing inside the flash. There is no firmware inside the flash. Now we will begin from here. I'll disconnect it and I'll connect it using the JTAG. JTAG which I am using is ESP32, the official programmer from the Espressif company. We can use other JTAG programmers as well. It's simply an interface, but right now in this session I am having the ESP32 JTAG, and there is a connection, a physical interface that you have to carry out before you can proceed with JTAG debug, JTAG based debug. So this is how you are supposed to connect. I mean, these 5 pins TMS, TCK, TDI, TDO and ground are there in the ESP32, and the GPS subsequently GPIO 14, 13, 12, 15 and ground is on the ESP32. You have to locate these pins and connect it using jumper wires or any other way you find suitable. So I mean, there's clock, data input, data output, ground, these are mandatory. You have to connect it before we can proceed with a JTAG based debug in ESP32. So I have already made this connection and my ESP setup, and we'll directly go to the terminal. The terminal is a lot of terminals are open. I actually forgot where I was working. Not in this one. Not even in this one. Of course not in ESP2. think I'll have to open a new session here. Let's go ahead with the new session. No. Okay, let's open a new session. So for doing this, you'll have to first locate the OpenOCD in your system. In my system, I have multiple OpenOCD installations. I have a standalone OpenOCD also, but it is more complex compared to the bundled OpenOCD that you get with an ESP32 toolchain. So in this session, we are going to use the OpenOCD which comes bundled with the ESP toolchain itself. So we'll go inside that ESP 5.5, which we have been using till now. And sorry, it's not there inside this folder. What you have to do is you have to do ls-la in your system. That will list out the hidden folders, and inside the hidden folder you'll find a folder named .espressif. So in my case, I can see the .espressif is right here. So I'll do a cd into this directory, cd.espressif, and inside the espressif we have to go inside tools. Inside tools you'll find OpenOCD-ESP32. This is what we are going to use. So go inside the directory OpenOCD32, and then further inside the version they have in the version folder. Go inside OpenOCD32 folder as well, and go inside bin. So this is where the bundled OpenOCD resides. What we have to do is we have to copy this path. So I'll do pwd and I'll copy this path here. Now second thing which we need to find is the configurations files. They reside inside the share directory. So one directory up from the bin there is share directory. Inside the share directory you'll find OpenOCD folder. Inside this folder you'll find a folder named scripts. Go inside the scripts folder. Inside the scripts folder, the folders of our work are interface and board. This is what we are going to use. There are certain other things. There are many other options which are available inside these folders. Different kind of configuration files are present, but for now, for our case, we are going to use interface folder and the board folder. The interface contains the ESP chip that we are going to use, and the board contains the ESP32 configuration file. So now what I am going to do, I am going to go inside the interface and first locate the file. So it resides inside the FTDI. Go inside the FTDI. In FTDI you have to look for the file that names something like devkit. So here it is, ESP32 devkit j_v1.cfg. So now we have multiple paths here. I'll open a text file and copy these paths so that we don't get confused. Path for session dot text, and I will paste it here. So this was our OpenOCD path / OpenOCD. This is our command that we have to run. Now we have to find the path of our configuration files to proceed. So we'll do pwd, copy this entire path and write the file name that is supposed to get accessed while flashing the chip. So this is the name of our file here. I'll put it here. So now we have our interface configuration file ready. Now we have to find our board specific, that is a devkit specific ESP32 specific file for properly communicating with the devkit. So I'll go back 2 levels up. Here I'll find the board folder. I'll go inside the board folder. Inside the board folder I have to locate for ESP32.cfg file. So here the list of ESP32 is there, and we have to use ESP room32.cfg. This is our file name. So I'll copy this file name and I'll put it here, and I'll get the path also. So I'll do a pwd and copy this path here into the text file. So now our configuration is almost ready. Now let's go back and write the command. Let's do it in this terminal itself. Let's do it here. So first I have to write sudo, run OpenOCD as sudo, otherwise it is not able to access files which are located in read-only folders. Now I have to get the command name which I saved in my text file, the OpenOCD command name. I'll paste it here. Then used -f key and provide the configuration file. Next. Next, use again -f and provide the board specific file. In our case it is ESP room. Some special characters have come. Next we have to provide the port numbers. So for GDB port I am providing 3333. Then I am providing telnet port 4444, and I think these options should be able to connect, because it automatically selects the interface as JTAG. Otherwise we can manually provide the JTAG name as well. Let me do enter. Yeah, as you can see, we are connected and the processor is in reset state. That is why uh, it is continuously resetting itself. Now for flashing the program onto this chip, we can access it using telnet. So I'll open my previous terminal. And because I provided the telnet telnet port number as 4444, I'll connect it using telnet. So here also you can see I can basically see the continuous reset of the code. Now for flashing it, I have to use the command called program underscore ESP. In the bottom left hand side you can see uh, uh, I have to use the command program underscore ESP, and I have to provide the bin file that I am supposed to flash. If you remember in the yesterday's video, we read the flash of our ESP32 and saved it as first esp.bin in my system. So we are going to use the same file and flash it onto this ESP32 using JTAG and then verify it. So now I am going to enter this command from my telnet terminal. So now it has erased the flash, and as of now it is flashing it onto the controller. Programming finished, verify OK. As you can see, after the flashing, the continuous reset of the controller has stopped. We can see in the other window as well, where we gave our OpenOCD command, that the continuous reset has altered. That means the program has been flashed. Now to verify whether it happened properly or not, what I am going to do is I am going to start the monitor. So I'll again change the USB connection from JTAG to the ESP32 and go to another shell where it is open. Yeah, it is open. We ran monitor here in the start of this video, so I'm going to run monitor here again. Let's see if the program of UART is inside this controller or not, which we flashed using the JTAG interface using ESP prog. So as you can see, the program is there inside the chip. The main app has started and returned. That means our task of flashing the bin file using the JTAG interface is successful. Thank you for watching this video.